Cystic fibrosis, the reason why I use it is because it's one of those diseases. Every time a woman has a baby, that's one of the number one thing they check is if does the baby have cystic fibrosis. They call it SID. SID. It's called sudden infant death syndrome. SID. SID. Sudden infant death syndrome. A lot of babies die from in the United States. It's not as bad, but around the world, it's very high. The death rate for babies is very, very high. As a teenager or as an adult, when you have cystic fibrosis, life is pretty hard. You need a spray. You constantly on medication. Constantly, you're always on medication because you have that genetic disorder, and then so you have to be very careful who you marry. Well, I mean, you can marry whoever you want in the society, but you let's say you marry somebody who has cystic fibrosis, or you marry somebody who's a carrier. You got to be very careful. A lot of couples, I know one couple who she has it, he is a carrier. So because of that, they have a very high probability of having a baby with cystic fibrosis. So she and her husband decided not to have kids because they don't want to risk having a baby with cystic fibrosis and suffer like her. I mean, that's a choice. I respect that. Okay? I respect that. So that is called cystic fibrosis. Not very good. It's not good. How many of you know somebody who has it? Anybody? You guys know somebody who has it? Okay, maybe they just don't share, but a lot of people have it. Okay, a lot of people have this genetic, and it's an autosomal genetic disorder. Now, what does that mean? It means this disease is not found on the X or Y chromosome. It's found on the chromosome number 1 through 22. So what does that also mean? It means that boys and girls can equally have this disease because it's not sex-linked. If it's sex-linked, one gender gets it more than others. Which gender? Male. Male gets it more. Why? Because boys, you only have an X and a Y. Ladies, you have two X's. Because you have two X's, if one of the X is bad, you have the other X. You're good. Boys, bad X, you got it. Bad Y, you got it. Okay, guys, we're good? Okay, all right. Okay, I hope that makes sense. Okay, so let's move on to how autosomal disease and how sex-linked disease, how it passes. Okay, so this is an example of a autosomal disease. Okay, autosomal disease. Remember that, right? Now we are talking about big ears and small ears. Okay, I just made this up. Okay, so big ears is dominant, small ear is recessive. So if you look at mom and dad, right? This is dad, this is mom. Mom has big ears. Mom has big ears. Dad has small ears. Now, they marry, how many kids do they have? 3, right? They have 2 daughters and 1 son. And the daughter has big ears. This daughter has big ears. The son also has big ears. The son that has big ears marries a woman with big ears. And they have 3 kids. What happens to all the kids? Big ears, and also big ears. All their kids have big ears. She marries him. He is small ears. They have 3 kids, big ears, because they got it from mom. She got it from mom. This son got it from mom too. Now, why am I showing you this? It's because if you look at the gender that gets this big ear, let's say this disease, female, 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 female. 1, 2, 3, 4, 5, 6. Right? Look at male. 1, 2, 3. Yeah. 6 female and 3 males. But this is a small sample. But if you look at a huge sample, you'll find that it's going to be equal to what? It's going to be about 50-50. So because this is only one family, small sample size. But if you look at 10 generations, 20 generations of this family, you'll find that it's going to equal to 50-50. Because it's autosomal genes. Autosomal genes does not say, oh, males you get it more, or females you get it more. Because it's not sex-linked. It's not XY chromosome. Now, so here's another autosomal example. Okay, so here another autosomal. This one is a disease called Huntington's disease. Okay, Huntington's disease. Now, what is Huntington's disease? Okay, this disease is when this is called the basal ganglia, which is the part of the brain that is the connection between your backbone to your brain. Okay, so your brain is up here. Your brain is up here, and this is your spinal cord. The basal ganglia is a nerve, a bundle of nerve that is kind of like the bridge between your brain, the central brain, and your whole body. This gets triggered sometimes later on in life. So you see how this lady, she has Huntington's disease. She's like a paralyzed. She's like a vegetable. You know what I mean when I say vegetable, guys? She doesn't move. Okay. So it is this autosomal gene shows patterns on pedigree charts than sex-linked genes. Okay. Autosomal shows different pattern. Now, what's the different pattern? Let me clear this up. Okay. This is the male, right? So I'm gonna count 1. Here's 2. Here is 3, 4, 5, 6, 7. 7 males, right? Now, if you look at females, 1 in this family, 2, 3, 4. Okay, you see what I mean? Okay, you guys see what I mean? So I should add males / females no, I'll check more later on, okay? Because I'm running out of space. I have to do more editing. Okay, so in this example, males and females are equally likely to get the disease. Unlike sex link, okay? Equally likely. So although this is like, I know it's not 7/7, but again, sample size, okay? Sample size. This is a small sample size. But if you look at a large sample size, you'll find that it's going to equal to 50-50, okay? 50-50. Now, here's another example. Here I have an example of a sex link, okay? If a specific phenotype is more common in males, gene is likely sex-linked, okay? Meaning because males, you only have one X, one Y. So if you look at this disease, I'm going to use the example of baldness, okay? So baldness is recessive. This is your problem, okay? It is sex-linked. Okay, baldness means you lose your hair. Men, that's why men, how often, guys, do you see a woman with no hair? Rarely, right? Rarely. I've seen 2 in my life, and I'm almost 50 years old. You see what I mean? I've seen 2. Women, I see them losing hair in the front, a lot of hair. I don't even know if it's this problem. It could be something else, but I've seen 2 in my 50 years, almost 50 years of life. So now here, it's this disease is on the X chromosome, sex-linked, X, okay? So that means that the Y doesn't have anything. So here is dad. Dad is normal. Mom is a carrier, C for carrier, okay? So mom's a carrier. She has this little M here. You see what I mean? Little M. Now, they have 4 kids, right? Now, the son is bald, B. This son is bald. Let me erase something so that you. I don't want the letters to mix up. Okay, so she's a carrier because she has a small M. She gave it to her daughter, but the daughter's a carrier because she's lucky she got this M here, which saved her. But the son, guess what? The son, it's only on the X chromosome. The son, you got it. Now, what happened to the dad? How come the dad has hair? How come the dad has hair? Because the dad has a capital M. He marries her, who is normal, right? Completely normal. They have 3 kids. Daughter, carrier. The son is normal because he happens to get the big X from mom. This couple, mom is a carrier, dad is normal. They have 4 kids. The son is bald. Now, looking at this, do you see any girls having it? Bald hair? I don't see any. You see what I mean? Because it's sex-linked. Sex-linked is a disease that affects males more than females. Okay? Sex-linked is a disease that affects males more than females. Why? Because males, we have only one X and one Y. That's it. Either one of those are affected, you got it. Okay? You got the prize. You got the winning prize. Okay. Okay, guys, are we good? Are we clear? Okay, let me show you another example. Okay, show you another example. This one is color blindness, which is also sex-linked, and it's on the X chromosome. Okay, it's only on the X. Now remember, there's more genes on the X chromosome than the Y chromosome. Okay, the Y chromosome is very tiny. Okay, so this is X-linked. So that means that it's on the X. So here is two families. Dad is normal. Mom, small c. Oh, she got it, guys. She's colorblind. Mom is colorblind. So that's one here. Okay. Now they have 2 kids. She is a carrier. He has it because he got it from mom. So he, number 2, got it. Right? This family, the dad has it. He's number 3, third person. See, he's a male and he got it because that's small c. The Y has nothing because it's not on the Y chromosome. They have 2 kids. Notice how here, the small c up, the carrier. Okay, she's normal. This 2 family marry each other. How many kids? 4 is affected. Carrier is affected. 5, and this is 6. So in this example, the reason why I kept this example is to show you that does sex link only mean that the males get it? No. The female could get it too, but the female can only get it if she has 2 bad X's. That's the only way for her to get it. This is the only way for her to get it. If she has 1 normal X, okay, if she has like a capital C and then 1 small c, she is only a carrier. You see what I mean? She has to be this. This is what you got to be. That's the only option. But for men, do you have a choice? You don't have a choice, guys. You don't have a choice. You're gonna get it. Yeah, one last fly, and then we'll take a 5-minute break, and then we'll cover lesson 2. Okay. So in this example, this one is called hemophilia. Okay, hemophilia. This is a disease where if you get a cut, this blood will never stop bleeding. Never, ever. And it's also a sex-linked trait, okay? Sex-linked on the X chromosome. Now, in this pedigree, they happen to switch. The male is a circle, the female is a square, okay? They happen to switch, okay? Now, how do you get it? This is how you get it. You gotta have 2 small H's, and you gotta have a small H. So female, male, right? So here you have this guy, dad has it. They have 1, 2, 3, 4, 5 kids. Carrier. That means the female is a carrier. Carrier female. Okay. Now, the carrier, a daughter marries a man who also has it. He has it. Affected. You see how? You look at this example. All the men has it. Male. Female can only be carrier. Not always the case, but the point is that men, we are more genetically prone to disorders than female because of our genetic, just the structure of our DNA. Okay, people, that is lesson 1. Okay, take a 5-minute break, okay? Take a 5-minute break. Okay, go take a 5-minute break.